Page 423, continuing lesson 8.2 on drawing geometric figures. If we look at example 3, an engineer makes a scale drawing of the floor of a building. The floor has two pairs of parallel sides that are 50 feet and 80 feet. Two of the four angles measure 60 degrees. Use geometry software to make this scale drawing. What is the name of the floor shape? Okay, so we're not going to be using geometry software. We're just going to do these by hand using rulers and protractors. But if we look at this, they're using a scale here. 1 unit equals 10 feet. And by using that scale, the 50 feet would be like 5 units, and the 80 feet would be like 8 units. Rather than units, if you wanted to use, say, centimeters instead, we could make that be like 5 centimeters and 8 centimeters. Okay, so then we've got two 60-degree angles. So they started out with the 8, we'll just say 8 centimeter segment and a 5 centimeter segment at a 60-degree angle. So you can make that 60-degree angle using a protractor. And then it said that there's two pairs of parallel sides. So if both sets of sides are parallel, then we're going to need also the opposite sides. The parallel sides are going to have to be the same length as each other. So if this was 8 centimeters on the bottom, we need 8 centimeters also on the top. This was 5 centimeters. We need this to also be 5 centimeters. And really, once we've drawn this, we already drew these and drew that angle. And then if you draw this 8 centimeters long, then automatically it's going to connect up to that other side. This would automatically be there already, and it should create this 60-degree angle. Angle D should be 60 degrees, just like angle B. And then also in the other corners, angle A and angle C should be the same. Those should both be 120 degrees because we've got 360 degrees total in a quadrilateral. And we can see that that shape then would be a parallelogram. So on the try it, we already talked about the try it A. If we look at try it B, again, we're not going to use geometry software, but we're going to make a rhombus with a side length of 6 units and two angles that measure 45 degrees. Okay, so for a rhombus, all the sides are the same length. So it says 6 units. If you want to use, make it 6 centimeters, you can. And we want a 45-degree angle, so I'll see what I can do with that on here. It gives me a way of actually using a ruler and turning it to a certain angle. Okay, and then once we get our 3 sides drawn, the other side should just come automatically. By connecting those together. You could measure it off as a 45-degree angle, but that should work like that. That came out pretty good, I think. And so what should happen, since this is a rhombus, we should have all four sides should be the same length as each other. So just a reminder, when you're doing the 45-degree angle, what you would be doing is you'd be lining this triangle up right with the edge of your line segment, and then after you had it lined up, you'd be looking for 45 degrees. So 45, there's two 45s on here, but we know it's an acute angle. So if the one side is here, to get a 45-degree angle, I want the closest 45 to that. So if you look at the numbers here, there's a 40, there's a 50. Right in between those two would be 45. So that's the 45 that I want. So what you could do, I'll make a blue mark here so you can see. You can make a mark above that, and then once you've made that mark, it's not going to stay for me, but you make the mark, and then you could either use the bottom of your protractor or use your ruler and then connect that. So you're connecting the edge of your other segment with that mark that you just made. And then probably would be best on this problem to use your ruler, because we want it to be a certain length. So we said we were making it 6 centimeters long. So then you probably use your ruler and measure off the 6 centimeters to that point. Okay, and then like I said, for this problem, the other stuff should all come automatically as far as the angles go, but if you want to check your angles afterwards and just verify that you have the right angle measurements, you can do that. So we're going to look at the do you know how number 4. So they want us to draw, it says freehand, we're going to use our protractors and rulers and stuff here. But we're going to draw a quadrilateral with exactly one pair of parallel sides and at least one angle measuring 45 degrees. So before we get started with this, we might want to think about what kind of shape this is. It's a quadrilateral, so it's got 4 sides. If it has exactly one pair of parallel sides, let's think about what that is going to be. So if you think about it, if it only has one pair of parallel sides, that's going to be a trapezoid. So in our minds, we would want to picture what that's going to look like. So it might look like that, or it might look like that, but it's going to be a trapezoid is what we should come out with when we do this problem. Notice they didn't say anything about how long the sides are. They just said we have a pair of parallel sides and we have a 45-degree angle. So there's different ways of doing this. One way you could do this, if you wanted to, is you could start out by drawing your parallel sides. So let's say if I draw a side here, and then if I go straight up from that, I can draw another side. Okay? If I know it's going to be a trapezoid, then I know I'm going to have something like that. Now, if you want to extend this out further, you can. Because what's going to happen is that we're going to make our 45-degree angle, and then we can decide by the 45-degree angle how long that other side needs to be. Okay, so at this point, I know you can't see this, but I've got my ruler here, and I'm getting it to measure out 45 degrees for me. Okay, so 45-degree angle, and I'm drawing that to connect it with my other line. So at that point, you could go and try to erase the part of that line that you didn't need. And then it said just really that we needed one 45-degree angle, so that's technically good enough there. That's our 45-degree angle. And then if you wanted to, you could just connect your other two lines to each other. Something like this. Or if you wanted to, continue it out and make it look like that other trapezoid we showed earlier, you could do that as well. Okay, and again, there's other ways of doing this. If you wanted to start just by drawing your angle and then just make your other line parallel to that other one below, you know, there's different ways you can do this and still get it to work. So if we look at number 5, it says use a ruler and protractor to draw a quadrilateral with 4 right angles, 2 side lengths each measuring 3 inches, and 2 side lengths each measuring 4 inches. And what's the most descriptive name of the figure you drew? Well, if we have 4 right angles, you know, I think we can probably freehand a right angle pretty well, that we probably wouldn't even have to have the protractor. I mean, I guess if we wanted to get it exact. Okay, so I'm just going to make some different measurements on the screen here and just try and be consistent on how I do this. So this is probably really more like 3 centimeters by how my ruler is. And the other one is 4. And then it's basically just connecting those at that point. I just free-handed that, so it's not quite perfect, but something like that. So these are all right angles, should be. And so the most descriptive way we could describe that would be a rectangle. We'll look at number 6. We're not using geometry software again. There is stuff out there. I haven't looked at some of it, but there's a program called GeoGebra. It's kind of like a combination of geometry and algebra, I guess. Anyway, there's things out there that you can look at that you can do some different things on, but we can do this with just a protractor and a ruler as well. So this time we want a quadrilateral. 2 angles are 80 degrees and 2 angles are 100 degrees. Okay, so going into this, we might not know exactly what this is going to look like, but it doesn't say anything about the side lengths, so we can just start drawing. So whichever you want to start at, I like to start on the bottom part, but if you want to start at the top, you can. So you need to make an 80-degree angle with that. So 80-degree angle. And then we've got 200-degree angles. So maybe over here on the other side, we can make that a 100-degree angle and see what happens. So 100 degrees, that'd be an obtuse angle. Okay, and then if you think at that point, if you made those lines the same length as each other, you should be able to just connect them. I don't have mine quite exactly the same. But we can connect those to each other. And you can measure the other angles actually kind of come automatically for you by doing that. So you really should only have to measure 2 angles on that one. So this would be a parallelogram. There's actually another option that you have. That's not the only way we could have done this. So another way we could have done this is let's just start with our bottom line again. And then if we did a 80-degree angle, and then let's say on the other base angle, let's say we did that as an 80-degree angle as well. Okay, and then what should happen if we connect those up here, automatically we should have our other angles, because we had an 80-degree angle and an 80-degree angle. So that's 160. So we have 200 degrees left. And if you'll notice, by having those 80-degree angles on the bottom, these angles are going to be the same as each other. So those would be 100-degree angles. So that would be a trapezoid. So there's actually more than one answer. There's more than one way that you could do this problem. So this gives you an idea of how to draw geometric figures. Have a good day.